Hello everyone. So in this video we're gonna talk about one of the most important techniques under integration because in the last video we learned integration by parts. That's one of the techniques that we use to convert a given integral to a standard integral, right? Standard integral that you can solve. So that was the idea behind that. Now you can't always use integration by parts to do that. In some cases, you may have to use a different technique, right? So integration by part is not the only technique available to convert integrals into standard integrals. I'll give you just one example. Now look at this integral example x into e to the power of x squared dx. Now, what about this one, this integral? This is a product. This is a product. Now, this is not exponential x. So, usually you are only familiar with exponential x. Now, instead you have exponential of x squared, right? Exponential of x squared. You don't learn this stuff, right? You don't even know what this is. E to the power of x squared dx, you don't know. Right? It's not given. So obviously what we have to do is that we can't integrate this one. So we can integrate this one, but we can differentiate it. Obviously you can differentiate this. So if I use integration by integration by parts, I can integrate this one. So x squared e to the power of x squared. This is x squared by 2. When you integrate x, then minus. Right. So you write this one x squared by 2. Then you differentiate. When you differentiate an exponential, you get the same function e to the power of x squared. But since you have x squared here, you have to differentiate this one and write it there. This comes from chain rule, right? So, but we can do it directly. So, in that case, what happens is that x squared, it becomes 2x dx. So I can get rid of 2 and x squared but 2 e to the power of x squared minus this becomes x to the power of cube ex squared dx. Right. Now what happened? What happened there is that what happened there is that this is the integral you started with. This is the original integral, but this is the integral you ended up with after using integration by parts, right? So what happens is that this integral is much harder to solve than this integral because you have only x here, you have x to the power of 3 here, right? So where does it end? So this is a good example to show you that you can't use integration by parts all the time, right? So using integration by parts made it worse, right? Made it worse. Okay, it's a note, which means we have to come up with a different technique to solve these kinds of integrals, right? So this is where we are going to use integration by substitution. So substitution technique, and before I get into what substitution means, actually substitution means what you did under chain rule. That's exactly what you do here. If you remember chain rule, under chain rule you what you do here is that you make a change of variable, right? Make a change of variable and you differentiate that, and finally you collect everything. That's what you do under chain rule. So it's the same thing here, and it's not that different. So before I get into that, I will explain a few other things because I have to run it. I have to go through them with you. Okay. Right. So now you should not think that every integral you get is in terms of x, right? So that's not the case. So here's the thing, if the function is given in terms of x, then this this is called a differential. This differential must be also in terms of x, right? Then only you can integrate. You can use the standard integers, and the answer has to be kept in terms of x as well, right? So you can see that this is x dx. Therefore, you can write it as x, right? X, the variable here, square divided by 2 plus c, where c is a real number, arbitrary constant. Similarly, in this case, u is the function here and du is the differential. You can see that it's the same letters. It's the same. It has to be the same letter. Then think of it as u. It's the same thing, right? You just have only u here. So this is u squared by 2 plus constant c. That's it. C is an arbitrary constant. Right? C is an arbitrary constant. Okay. Now look at this integral. This is sine of t dt, right? Same variable, tt, same variable. So integral of sine, think of it as integral of sine. Don't care about the variables. Sometimes we call these dummy variables. We call them dummy variable because once used you can throw it out. So sine of t, what do you get when you integrate sine of t? You get minus cosine of t. Cosine of t plus c, where c is a real number, right? So please keep in mind, so it doesn't matter what the variable is, as long as it fits your model, right? As long as it fits your model, then you can integrate. We stick with the x variable all the time because in mathematics we use x and y. That's the only reason. But if you change variable, that's fine too, right? Okay. Now we'll get into this technique, what is meant by the technique and what do we do in the technique, right? In the technique that is called integration by substitution. Okay. Right. So this is technique, right? Summary of the technique. So under integration by substitution, when you use this substitution rule, what it does is that it converts a given integral of a certain variable, into another integral of a different variable, right? Now these two integrals are the same. They are the same. The only difference is that the variable has changed. So that's why I said another integral, right? So just by the look of it, you don't see that they are equal. Right, they are equivalent actually. What it does is that when you apply the appropriate substitution, change of variable, right? Change of variable x to u. We'll see how to do that. Then your original integral will be transformed into another integral which is easy to solve, right? So I mentioned this is easy and I mentioned difficult. If this can be solved, then don't need to use any substitution technique. You can just integrate as it is, right? So this is the basic summary of integration by substitution. So under this, in the exam, sometimes this substitution will be given, and sometimes you have to come up with a substitution. So we will look at some examples after this, and we will look at some models, right? So there are certain models that you have to memorize, right? So which substitution that you should use for a particular integral, that you have to memorize. So we will discuss maybe 10 or 13 substitution techniques in the class, but in this video I will discuss some basic substitution just to convince you of the process. Right. So let's start with the basic substitution that you can use. This is also called U substitution because we usually use the letter U here, right? So it doesn't matter what letter you use, you have to change the variables. Now look at this. You already know the integral of this one. The integral is, since this is a linear function, right? So you can see that you don't have x squared, x cubed, those terms. You only have x term there. Since this is a linear, that's why you call it linear function, then the answer is ax plus b raised to n plus 1 divided by n plus 1 plus c. Right? But this is the basic integral, you know. This is actually a derived result, right? Derived result from this. So x to the power of n, integration, power rule of integration. So x to the power of n plus 1 divided by n plus 1 plus c. Now you can see that instead of ax plus b, if we had x here or just one letter, one variable, then you can use this, right? You can do the integral similar to this one. This is what we are going to do. Now, since this is a linear function, I am going to change the variable. If you have only just one letter here, one variable here, instead of ax plus b, then you can definitely integrate it. This is what I am going to do. So I am going to show you the substitution. U equals this, ax plus b, right? This is the first step. Show the substitution. Then after that, just like the chain rule, differentiate it. So if I differentiate it, du by dx equal, this becomes a plus b goes to 0. Right. Next, what you do, so the objective of integration by substitution is to convert the integral given in a certain variable to an integral of a different variable. Right? So completely it has to be transformed, which means when you transform this using this substitution, the resulting integral must be in terms of u alone. Right? You can't have dx terms. So now we can see here that we have du dx, a relationship between du and dx. So what I can do here is that I can convert du over a equal dx. Now you can see we can change this thing which contains x by u. You can replace this whole thing by u. And what about dx? Now you can replace dx by du over a. Right? This is the conversion. Okay. Now convert this integral. Instead of ax plus b, write u to the power of n. Instead of dx, write du by a. Du by a. Right? Now this is a constant, so I can factor it out. U to the power of n du. Now this is a standard integral, like this standard integral. You can see this is the same letters, same variables, right? Same variables. So what you can do is that the answer is u to the power of n. So 1 over a u to the power of n plus 1 divided by n plus 1 plus integration constant. Right. Now, u is something you introduced into the problem which was not already there. In the final answer, you shouldn't leave the final answer in terms of u because this is something you introduced. ඔයා ගානට දැම්මේ. ගානේ කොහෙවත් u දීලා තිබ්බේ නැහැ. ඔයා දාපු එකක් ඔයා අයින් කරන්න ඕනේ. That's why we call these dummy variables. Dummyයක් කියලා කියන්නේ ඔයගොල්ලෝ දන්නවා dummy පාවිච්චි කරන්නේ අවශ්‍ය වෙලාවට විතරයි. ඊට පස්සේ අයින් කරනවා. හරිද? Dummy variable. Now your answer is in u. So what is u? U is ax plus b. So we can finally write 1 over a into let me put brackets there. So it should be ax plus b raised to n plus 1 divided by a times n plus 1 plus c, where c is a real number. Right. So now you can see that. So this is the first example. How we converted this integral into a known integral, standard integral. Right. So now let's look into more examples until you get what this process is. So now you can see that you have to write the substitution. Sometimes in the exam the substitution will be given. Most of the time you have to come up with your substitution. So we will discuss certain models in the class. Then take the derivative and write dx. Right? Isolate dx and find dx in terms of du and other constants, right? So then after that you can change everything. Okay, this is the basic idea. Okay, now we'll look into another example. Right, this is another example. If you can remember reverse chain rule, which we did in the class, integration by reverse chain rule. So you can see that here that the derivative of this is in front of it, or can be made to be the function in front of it, right? So we can use reverse chain rule. Now, I mentioned there the reverse chain rule is a result from integration by substitution. So this is where we learn it, right? So what is the substitution? You can see that the derivative of this one is in front of it, or can be made to be the function in front of it. So I'm going to make the substitution, this u equal 2x squared plus 1, 2x squared plus 1. Then do this, du by dx is equal to what? 4 times x only. Then isolate dx. So du divided by 4x. du divided by 4x. Okay. Now do the substitution, change of variables. So write x, don't worry about it, write x, then this can be substituted by u. So u to the power of 3, then dx can be replaced by du over 4 times x. Now notice here you can cancel this out, right? Then 1 over 4 u to the power of 3 du. So now 1 over 4 u to the power of 4. This is similar to this, u to the power of 4 divided by 4 plus c. So finally you have to write u, write the final integral in terms of the original variable, which is in terms of x. So this is 1/16 2x squared plus 1, 2x squared plus 1 to the power of 4 plus c, where c is an arbitrary constant. You always have to put integration constant if this is indefinite integral. Indefinite means you don't have limits. Okay. Let's look at another one. Right, now look at this one. Right, just by the look of it, you get afraid of it, because this is e to the power of sine inverse of x. We don't even know what the integral is, right? Divided by square root of 1 minus x squared. Now from reverse chain rule, you know that the derivative of this is this 1 over square root of 1 minus x squared, right? So now this is something unfamiliar to you. If you had this e to the power of x dx, then you know, right? So if you had e to the power of x like this dx, then the answer is ex plus constant, right? That is the answer. But you don't have that here. We have other terms as well, because this is different, this is strange. It should be x here, right? So let's change this. Write this as a single letter, a single variable, u or t or whatever you like. Now let's take t. T is equal to sine inverse of x. Right. Next, take dt by dx. What do you get? 1 over, when you differentiate this one, you get 1 over square root of 1 minus x squared. Now, write dx in terms of other variables, dt, so dx cross multiply, then this one goes here, square root of 1 minus x squared into dt. Good. Now change. Write e, then in terms of, instead of this, write t, e to the power of t, right? Then write this one as well, 1 minus x squared, square root of 1 minus x squared, that is fine, right? Now change dx. Dx can be changed by square root of 1 minus x squared dt. So notice here that these two cancels out, right? Finally you are left with e to the power of t dt. Wow, one of the simplest integrals. Actually, this is the simplest integral, right? Just like the simplest derivative. So et, standard integral. You don't have 2t, 3t, anything, just et. So the answer is e to the power of t plus c, where c is an arbitrary constant. Right. So you can see that how we convert this integral to something very easy to solve. Right. Now this is the integral. Can you guess the integral? Let's get it. Can you guess the substitution? Relevant substitution. You have a square root and you have x on top, right? So we learned under standard integrals where how to integrate these when you have only constant here. Now we have x, right? So we learn another technique that says that if you had an integral like this of this form, where you have a square root in the denominator, and in the numerator you have the derivative of the function inside the square root, then this is equal to 2 times square root of fx plus c, right? You can use this as well, but this is where it came from. This is where it came from. Now replace this one, x squared minus 16, in terms of by another variable. Let's say u equal x squared minus 16, then du by dx, differentiated, you get 2x only. So that means du over 2x is equal to dx. Now we know how to replace this one, because it's difficult to work with square roots. That's why we substitute the expression inside the square root by another variable and see whether it will be transformed to an easy integral. Right. So in that case, so x is on top. We are not doing anything to that. Square root. So inside the square root, this is u. So square root of u. Then instead of dx, we can write du by 2x. Good. So we can cancel x and x here. 2 can be taken to the front, and this is u to the power of half. I can take the reciprocal of it, and u to the power of minus half du. Right. So this is half. You add plus 1 to it, then it becomes half, and you have to divide it by half as well, plus 6. So half cancels out, and finally you have u. What is u? X squared minus 16, x squared minus 16, a square root of this, right? Square root of this, and because you have a half here, so this half cancels out, plus c, where c is an arbitrary constant. It's the same thing. Notice you didn't have a 2 here because you had to have a 2. When you differentiate this one, it should be 2x, but you don't have 2 here, so there should be half. Okay. Now look at this integral, right? This is a rational function, right? But it's not a polynomial actually. This, let's call it quotient, right? So in the denominator you have a combination of trigonometric functions, and in the numerator also we have combination of trigonometric functions. Now notice the coefficients are different. Now if you look closely and observe this, you would see that this is the derivative of this one. This is the derivative of the function in the denominator, right? You should see that, because when you differentiate this one, you get 3 cos x minus 4 sin x. That is that. Now let's can you guess the substitution now? Let's say t is equal to 3 sin x plus 4 cos x. So now let's differentiate this with respect to x. So dt over dx is equal to 3 cos x minus 4 sin x. Right. So this implies dt over 3 cos x minus 4 sin x is equal to dx. Let's convert. So instead of this, I can write t we have 3 cos x minus 4 sin x. Then dx can be replaced by dt over this thing, 3 cos x minus 4 sin x. So let me use brackets. Okay. Now you can see that this thing cancels out, and finally you have 1 over t dt. 1 over t dt. What is that integral? This is 1 over t, right? So what function on derivation will produce 1 over t? That would be ln of t plus c, where c is a real number. Where c is a real number. Okay, right. And so now finally you have to replace t, but okay, so you have replaced t, so it should be ln 3 sin x plus 4 cos x plus c. Right. Okay, good. Right, so let's look at this one for the final example here. So this is what I started with. I showed you that we can't use integration by parts here, so it will make things worse. So what is a substitution? Can you guess? Notice something weird of the functions, right? Notice the weirdness and replace that weirdness by the standard. We have e to the power of x squared, so let's use substitution. U equal x squared. Then du by dx equal 2 times x, which means du over 2x must be equal to dx. I just cross multiply both sides, and now I can change the variables. X is there, e to the power of, instead of this I can write u. Then instead of dx I can write du over 2x. Good. Now I can get rid of x here, x goes off, and finally eu du. Wow, right? This is the simplest integral, so the answer is eu plus c. Now change u back to its original substitution, original variable. This should be x squared plus c, where c is a real number. Okay, right. So we will talk about models, right? Models that you can use in the exam if given. Sometimes they ask, right? So without giving the substitution, they ask you to solve this using an appropriate substitution. In that case, it's a bit difficult, right? So you have to memorize these substitutions in addition to the standard integrals, right? So when you look at the exam nowadays, I think there's a trend that they give us the substitution, and also sometimes it's very it's very obvious, right? So when you look at the problem, the substitution is obvious in most of the problems that you get nowadays. So you don't have to worry too much. But when you do practice more questions on integration by substitution, you would do the problem in the exam. Okay, so thank you for watching. We'll see you guys with another problem.